It's funny.
Okay, homework. New homework, sorry. All right, hey, we're going to run through this fairly quickly, right? We should end early. We also won't do the entire process. We'll do like the first 2 or 3, the full process, and then we'll say, okay, just do the process, and we'll just get to the shapes themselves. All right, everybody good? Evelyn, there wasn't an extra sheet. Should have been. Nick,
Oh, okay. Did you get one? Oh, geez.
were you guys not here or something?
No, they won't. I'm just a bad.
I print out 16. I have 16 students, so it should always be the right number unless somebody's absent. So there still should be one extra. That would have been issues. All right, everybody good? All right, here we go. All right, so a bunch of weird words we'll talk about when we get to them. All right, recall from last class, right? If a shape has symmetry, we can use that trick to allow us to graph it with fewer points. There are 3 basic symmetries. The first one is polar axis symmetry. Polar axis, in this particular case, the polar axis goes left and right. Therefore, if we graph the top, we can duplicate it as the bottom. We just flip it over it's not the x-axis, it's the polar axis, but yes, it looks like the x-axis. And the relationship for theta would be theta and negative theta. In other words, if we replace in the original equation negative theta for theta, and we simplify, we get back to the same equation, then we can confirm it does in fact have polar axis symmetry. That's the test for symmetry. Replace theta with negative theta, see if it gives you the same equation. And if that's the case, it has polar axis. So all you need to do is graph half of it and then reflect it over the polar axis, right? The second one is, it sure looks like y-axis symmetry, but there is no y-axis on the polar plot, but there is pi over 2. Right? So if theta is equal to pi over 2, that vertical line right there, then we can reflect it over that line if it has left and right symmetry. In other words, you can draw a dotted line straight down the middle, and it breaks it into a mirror image of left side and right side. In terms of theta, though, that would be theta and then pi minus theta. So we replace theta with pi minus theta. See if we get back to the same equation. If that's the case, then it does in fact have theta is equal to pi over 2 symmetry. The last one is the pole symmetry or symmetry with respect to the pole. This is the one where if you take the shape, you turn it 180 degrees and you get exactly the same shape, then it has this type of symmetry. So we take theta, we add pi to it, that would be 180 degrees. You get back to exactly the same shape or the same equation, then you can conclude that it does have symmetry with respect to the pole. All right. So those are the 3. You had those last night for homework. The difference was we only had one basic shape. Now we're going to add to our knowledge base of weird looking shapes. The process is always we test for symmetry. It's either going to have symmetry or not. We'll do only one example where you have no symmetry. What do you do then? But all the other ones will either have 1 symmetry, 2 symmetries, or 3 symmetries. Once we figure out what symmetry it does, we do a shortened table of pain, table of values. We have 3, 1 for each symmetries. We pick whichever symmetry we have. If you have multiple symmetries, you only got to pick 1 and then graph it and apply the symmetry to it. Once you apply the symmetry to it, you get for free double the points. All right, from last class, just one quick example. This was the equation right here. We determined if it has symmetry. It doesn't matter which one you start with. But if I start with the polar axis, that means replace theta with negative theta. Hey, we have an odd function. Odd function, the negative goes to the front, and 2 negatives make a positive. So we get 1 plus sine theta, and that is not what we started with. So nope. Anybody see the movie? Yeah. 2 years ago? 3 years ago?
Wasn't that a scary movie?
It was about aliens? Yeah. Was it scary?
Like
I never saw the movie, but I just remember the commercial for it would go, nope. All right, so no, red and red do not equal each other. So go to the next symmetry. Theta is equal to pi over 2. Replace theta with pi minus theta. Unfortunately, this means we need to use the sum and difference formula. So we use the sum and difference. This one's difference. So sine, cosine, sine, with a minus sign in between them. That's convenient because the sine of theta is, or sine of pi, sorry. Sine of pi, y value at pi, big fat 0. For cosine, that would be a -1. We do a little bit of simplifying here. 0 is 0. Two negatives make a positive, but we got a third negative, which does in fact make it negative. And look, red is equal to red. So therefore, this does have theta equals pi over 2 symmetry. The last one, same thing. It's going to be sum and difference, except this time it's going to be sum because we're replacing theta with theta plus pi. Same drill. It's going to be sum formula for sine. That's sine, cosine, sine with a plus. Alpha, beta. Cosine of pi, pi is -1. The sine of pi is 0. Bring that negative to the front, which makes it positive, and red does not equal red. So this one only had theta is equal to pi over 2 symmetry. All right. So what do we do with that? Then we do our shortened table of values or page. So remember, we have 3 of these, and yes, I wrote the table backwards. It should go r theta as a ordered pair, but I'm doing the theta first because that's what we're plugging in. So we're doing a theta r formula. So what are those 3 table of values for the short one? For the x-axis symmetry, in other words, the polar axis symmetry, right? We simply use 0 to pi, all those values. For the one that we have for the y-axis, or the theta is equal to pi over 2 symmetry, we use -90 to +90. And then for the last one, for the symmetry with respect to the pole, we use 0 to 180 for this one as well too. All right. So we take these values for theta. Remember, my table here is backwards. Table should go r theta, but I'm doing theta r. We simply take these theta values, throw them in for the equation one at a time, and see what we get. This is simply a calculator drill. We repeat all this. I'm going to zip through this really quickly. We did this yesterday. We get values, and those values are what we're going to use to graph. This particular one produces a cardioid or heart-shaped figure. And then we finish class by writing this down. Why are you not clicking? We finish this by writing all this down as a cardioid. So today we will continue with the remaining shapes. Okay. All right. Quick caution, right? Most of these equations all look alike, right? There's going to be the word sine or cosine. There's going to be some numbers involved, and they kind of get jumbled. So having this on your resource card when we get to test day is how you keep this track. They all have different and weird names. Some of them will make sense. Some of them will be, most of the ones that don't make sense are French words, right? You just simply need to have a familiarity. You don't need to memorize anything. You need to have familiarity with the process, and you need to have familiarity with the formulas that we write down. All right, so this was the first one. Do you guys need to write this down again, or do you have it from yesterday? That would require you to give me an answer.
All right.
Okay. So if you are a cardioid, you do go through the origin. You will always go through the origin. It is, okay, I guess it's somewhat heart-shaped. To me, it always looks more like an apple, or somebody said a peach yesterday. Definitely looks more like that to me. That A value is always greater than 0, but between the A and the A cosine or the A sine could be a plus or a minus. Doesn't mean A is negative, right? It just means it could be a plus or a minus. And we played with this with our calculator, right? A determines the size of the lobes of the apple or the heart. The plus or the minus determines whether it's flipped or flipped. And then the sine and cosine is the rotation 90 degrees. All right, everybody good? All right, on to the new shapes. All right, remember the process, right? The process is determine the symmetry, right? Graph and apply that symmetry, and you're done. All right, does this look like the previous one? Does this look like a cardioid?
Well, does A have to be the same?
So she notices immediately A is not the same. So the difference between this and a cardioid is A is not the same. You see that? Further, you see the relationship between the two numbers? First one is bigger than the second one. Those are the cute, well, that's the only feature that you should pay attention to. Hey, it's not a cardioid, and the first number is bigger than the second number. It will result in a specific shape. Okay. All right. So the process is test for symmetry. Doesn't matter the test you do first, but I always go in the order I gave them to you. So I replace theta with negative theta, right? So I'm testing for polar axis. This is an even function. What happens to the negative? Ooh, goes away. So since it's an even function, then red equals red, and this one has polar axis symmetry. Or x-axis symmetry. How about that? All right, let's test for theta is equal to pi over 2 symmetry. We replace theta with pi minus theta. We played this trick before, except this time it's not sine, it's cosine. So I need the difference formula for cosine, or the difference identity for cosine. So this one goes cosine, cosine, sine, sine, with what in between? A negative, same sign, right? No, opposite. I screwed that up, and I agreed to you.
What?
I caught my mistake.
I thought.
So it's opposite. If it's a minus, it's plus. Okay, well, that's convenient because we already know the cosine of pi is
Negative one.
negative 1, and the sine of pi is 0. So that negative 1 would turn that 2 into a negative, so therefore we do not get the same thing. So it does not have theta is equal to pi over 2 centimeters. Big fat nope. Last one is we'll replace it with theta plus pi. You should probably see what's about to happen here. This is the sum or difference, so this time opposite signs, cosine, cosine, sine, sine. Too fast?
No.
Okay. Cosine of pi is negative 1, sine of pi is 0. The negative moves to the front, and so, yep, we got two symmetry. Oh, sorry,
No,
negative. I convinced myself. It's the next one that we see that's going to happen.
Well, if it has one, does it have the other?
It may or may not, right? Sometimes you can see the logic behind it, sometimes you can't. All right, so what was the reduced table of values for polar axis?
0.
2,
0 to pi.
0 to pi. So 0 to 180. All right, we have 2, 4, 6, 8 people. Guess how many blocks we have? 1, 2, 3, 4, 5, 6, 7. So who gets to be the lucky person out?
Me.
All right, first one you, second one you. We're gonna do a bunch of these. All right, so Leaf, this is yours. Nick, yours. Matt, yours. Abby, paying attention? This one's yours, Abby. Seth, Evelyn, and Princess. This is an easy one. You could do this in your head.
No. Okay. Can I?
You already know what the cosine of pi is. What's the cosine of pi? Priscilla. So that would be 2 times -1, which is, what's 3 minus 2? Wow, you did the whole thing in your head.
Okay.
First one, Leaf. You have a calculator. If it was a snake, you'd be dead. It's right next to your hand. Grab your calculator, throw in 0, or think about what's the cosine of 0. Cosine of 0 is not 0. Cosine is x. What's the x at degree 0? 1. 1 times 2 is 2. 2 plus 3 is, your calculator better said, 5. It's going to take forever. Nick?
5, but 4.9.
4.9? Something like that? I got 473 is what I got. Are you sure you got 4.9? You typed in pi over 6?
It's in degrees.
Oh, that's why.
Can I say mine?
No, got to do them in order. Yeah. Matt? Abby? Seth? Boy, there's a pattern here. 5, 4, 3, 2. 1 point what? I got that. And then finally, you said the answer was? Yay. What do we do with all that? We graph that on graphing. And then for free, we get the opposite. But this has polar axis. So what's the opposite? What do we get for polar axis? We get, here's this shape. So polar axis means to flip it which way? Up to down. So let's see. This dot would be right here. This dot would be right here. This dot would be midway. This dot would be here. This dot would be here, and that dot would be there. So I get, when I play connect the dots, we get that shape right there. Hey, that looks like, still looks like cardioid, right? But notice our cardioid does not go through 0, 0, right? Doesn't go through the pole. I didn't come up with this. I don't know who. I should probably know that, but I don't. But mathematicians look at this and they say, well, we're not going to call that a cardioid. We're going to give it a new name. You ready? Paying attention? Right? Clearly somebody French came up with this because it has a French name. What are the French famous for?
You should ask Jaden that question. He thinks the French.
What are they famous for?
Good name.
What are the stereotypes of being French?
Eiffel Tower, being rude.
Striped shirts,
Aggressive.
baguettes,
Mine.
bicycles, berets.
Mine.
They're always on a mimes. They're always on a bicycle with a baguette in their hand. I have no watch. They got a red beret on. Ratatouille, right? So, speaking of Ratatouille, French chef. So if you go to any movie about French chefs, what will the people be eating? Besides baguettes.
Cheese and wine. Pasta?
It's always about the American who doesn't understand the French, and they go to a French restaurant and they throw a plate in front of them, and guess what's on the plate?
Burger?
No. Every single stereotype about the French, if it's at a restaurant, they're going to be eating.
Cheese.
No.
It's not cheese.
They're going to be eating snails.
Escargot?
Right. Because that's the common stereotype. So don't ask me why. I don't know. But when people look at this shape, they whoever came up with it's like, okay, cut this in half,
Escargot.
and it looks like a snail shell.
Are you serious?
Yes, I'm serious.
No, that shape. So stupid.
Yes.
That's sad.
No, it's not my favorite shape. I didn't say that. It's my favorite story, right? Right.
Oh my God.
It's not my favorite shape, right? If I did say it was my favorite shape, then I was not being truthful, right? The word for snail in French is escargot is the edible. Not all snails are edible. If it's just escargot is edible snail in French, right? But the word for snail is, I think what I said yesterday, it's my favorite word, right? Is this one right here.
That is awful.
Say it.
Limousin. Okay, so this is Limousin's come in 2 flavors. Flavor number 1, I'm hungry now.
For snails?
Oh, I love to eat snails.
What?
Oh my God.
They come in a special container, right? When you get it served, it'll come on a dish, and the dish looks like, I don't know how to describe it. It's usually circular, sometimes rectangular, but it has little like hemispheres cut into it, like after the hemisphere. And then the snail sits right in the middle of that hemisphere. And then, do you know who Pluto is?
Yes.
Hades?
Yes.
Neptune has a trident, right? He has with how many points?
3.
Pluto has one with 2.
Oh.
So when you get escargot, it always comes with a special fork, and the fork has 2 tines to it. It's called an escargot fork. They're not that expensive. Right? I mean, usually people don't eat escargot as your main meal. Usually eat it as an appetizer. So I'll just say it certainly sounds weird and disgusting. I've never met anyone who's actually tried it and said, "Oh my God, that's weird and disgusting."
What does it taste like?
Mushrooms. Right? If you ate mushrooms, then you will not like escargot. But usually they're cooked in butter and garlic, and it tastes like mushroom and butter and garlic, except it's a snail. Okay. Yes? Okay, make yourself a snail. How do we make ourselves a snail? Grab your calculators. How do you make a snail?
Just by typing it
Yeah, but what does it got to be? Yeah, but what? How?
in.
I need 2 numbers, but what's the relationship between the 2 numbers?
One has to be bigger.
The first one has to be bigger than the second one. So grab your calculators. Give me a snail.
6 sine beta.
And you should get a snail.
A cute snail looks like. But that's not cute. Yeah, that's not.
It doesn't look like a snail to me.
I agree. I fully agree. I've never seen a snail in this shape, but that's what it's called.
So what's the difference between this and a heart?
Well, the heart must go through
Oh,
0,
okay.
0, right? Whereas a limaçon does not go through 0. I just say it looks exactly like the heart one. It just doesn't go through 0, 0. But it's called a limaçon. Who's the knucklehead that always comes to me and says knuckles, and then they go snail? So instead of saying that, you should say limaçon.
Vivian, does Vivian do that too? She's
No.
always like, no, snooze.
There's some kids who go by like Kai does it to me a lot. But Kai's not in pre-calc, so he can't say the fancy word.
You should say it again.
He would not even know what I'm doing.
Exactly.
All right, good. Clearly the next one's going to be this with a loop. All right. So here we go. Hey, what's the difference? First number is smaller than the second number. All right, same process again. Polar axis symmetry, we throw a negative. Cosine is an odd or even function, so the negative goes away. So yeah, this one has polar axis symmetry. I'll do this very quickly. We've done this now, it feels like 5 times. Cosine of pi is -1, sine of pi is 0. The negative would move out to the front, which would give me a negative, and that's not the same. Nope. And then for symmetry with respect to the pole, cosine of pi is -1, so it gives us a negative. So nope for that one as well too. All right, so here we go. You know your numbers this time. Princess, you can take a break, and Winter, you're up.
My calculator. Give me a second. I don't know what she did.
So the graphing calculator, you're going to see this eventually if you start throwing in some really big numbers. Finally, your calculator kind of freaks out a little bit, and you start getting stuff like this.
She
She
did
did
the
the
eight. She did the exact same thing that we
Evelyn
did. The
did.
8 minus
6
sine.
You didn't break it. I just typed in something special. Now try it again. This is gonna.
I got a negative. Is that okay?
Yes.
Okay, cool.
All right. Do you know what you're doing? Leaf 0. You can do that one in your head. Cosine of 0 is, what's the x value at 0 degrees? 1 times 2 plus 1. So we get a 3. Winter, pi over 6. You're talking to yourself, Winter.
I know. I'm not having a day. I'm having a day.
1 plus 2 times cosine of pi over 6.
This is graph mode, not
I know.
this mode. So I had to go back. 2.7.
Okay. Nick? Matt? Same answer as the previous one. It's 1. 2 times 0 is 0. 0 plus 1 is 1. Type in pi over 3. 1 plus 2 cosine pi over 3. I'm sorry, you're doing 2. Nick, or you're doing pi over 2. I said pi over 3. I meant pi over 2. So that's your 1. Abby got a 0. Seth, you got a.
That was my number.
You have the last one.
No, I have 5.
No.
Yeah, that's.
Princess got this one off.
same numbers as I can do.
Cool? Everybody good? All right, we just said to graph this, polar axis means flip it over. Flip it over what? Except there is no x, it's polar axis, right? Okay, so that means the top goes to the, and the bottom goes to the top. So if we flip the bottom to the top, you get that. There's your inner loop. And if we flip the top to the bottom, there's that. Horribly drawn, but you get the idea. Okay, so you get this thing, and it looks exactly like the previous one, except it has an inner loop. Now, unlike the previous one, notice this one does go through 0, 0. Right? So this is going to be called a limosol with an inner loop. Write that down. And notice, just like a cardioid goes through 0, 0, the limosol with an inner loop goes through 0, 0. A normal limosol does not go through 0, 0. You type it into a computer and let the computer do it for you. I don't know. The only I speak German, I don't speak French, but the only reason I know it's limosol because that's what Siri told me. We don't have a French teacher, so.
I thought that.
Well, Spanish will probably always be offered as one of the language, and then if we offer a second one, it's going to be depending upon who, if the person speaks that or not. You know.
Well, but
Lower school.
I thought that, yeah, lower school had like French for a while there, I thought.
Who was doing it?
I don't know, but it was like, 'cause I remember.
If there was a teacher that spoke French, that's probably why.
Yeah.
When Caden got his schedule in the beginning of the year, he got, like, there was this paper and it said French class. He was supposed to have to take French, but he's not taking French.
And then I was supposed to do Latin, Spanish, and French.
Yeah,
Who's
and
getting all
Bradley's
three?
in the same,
Nice.
is in the same grade as her.
Because her Spanish grade is at
What
4.
grade?
Fourth.
Fourth?
Yeah.
I'll have to
Spanish
ask.
grade is 4.
I didn't even realize that was happening. All right, everybody has it written down? All right, grab your calculators, you know the drill. Give me a limosol with an inner loop. Grab your calculators, give me one with an inner loop. Second number has to be bigger than the first number. Yep, you got a little tiny inner loop. Yours is a little bit bigger. So what were your two numbers?
2 and 3.
2 and 3?
No, 2 and.
Did you get one?
Good job.
So
I'm so proud of you.
That's ugly.
Stop.
You got two of
Something
them.
like my mom.
Well, the black one is.
Whoa, mine looks cool.
Let me see. All right, cool. All right, so that takes a minus key.
No, how do you put a dot on a negative? Like pi,
Words came out of your mouth. I have no idea what they meant.
Yeah.
like pi -1. Where do I put that?
A pi to the -1.
Like on the one that were the thing with the inner loop that we're just supposed to graph, it says pi -1. Where do I put that?
Show me. Oh, right. Now I get it. Now it makes sense. She was saying it right. We were just not understanding what she meant. Okay, remember, how do we graph a -r? So give me a theta.
Pi.
So pi is this direction, right? So positive r would be here, negative r would be in that direction. So you follow the radial in the opposite direction. I need to throw that marker away. It's not. All right. Cool? Ready for the next shape?
The flower, the rose.
We'll see. All right. So we're going to graph this equation. What do you notice about it as compared to every one that we've done before this? It's times instead of a plus or minus. I still have two numbers, a 2 and a 2, but I have no pluses or minuses. Okay. So let's see. Polar axis symmetry, -2 theta. Well, luckily for us, sure feels like we would need to do a double angle formula right here, right?
Yes.
All right. So double angle formula, we got a negative, so I don't have to worry about the negative. it's cosine, so the negative disappears, right? So we get that, and luckily I don't have to worry about the double angle formula. Why? Because, well, red equals red right now. So for that particular one, life is good. So this one has polar X symmetry. For this one, oh, we got to do some thinking. Ready for this? It'll be easy. You ready to do some thinking? Matt, you ready to do some thinking? What does this literally look like on the inside right now? We don't overthink it.
2 pi minus.
So he's saying he sees a sum or a difference. I agree, but let's think even easier. Say it again.
2 pi minus beta.
Seth and Evelyn said, hey, look, we can distribute the 2 to the inside. Let's do that first, right? And then we're going to use a trick. This literally says, what's the periodicity of cosine? When does cosine repeat itself?
Every 2 pi.
So guess what this means?
That it's the same.
It's the same, so I can take my eraser and erase that, so it turns into that. And we already said that cosine is a,
Even function.
when I draw cosine or sine, it repeats itself every 2 pi. So if I take 2 pi and either add or subtract it to whatever I have, this gives negative 2 theta, I'm just repeating myself. The value is going to be exactly the same, so I can literally just ignore the 2 pi. And we said that the negative for cosine disappears, so therefore, look, it's the same. So this one has 2 symmetries. Maybe it will have 3. Let's see.
It will.
It will, because it's the same trick. We distribute the 2. Cosine still repeats itself every 2 pi, so the fact that I'm adding 2 pi doesn't change anything. It's just that, and that's the same. So this one has all 3 symmetries. It has all 3 symmetries. Yes? Okay, what would be my next step? I got to pick a table of pain. I got 3 to choose from, so guess what?
The easiest one?
Choose whichever one you'd like. They're all the same difficulty, right? They're all just plugging in 7 numbers into a calculator. Oh, no, I said that once we did the first 2, we're not going to do it again. I'm just going to say, then you would do the process. But what I'm saying is, tonight for homework, when you get a choice, if it has more than one symmetry, then you simply pick one and apply that table of pain. So I'm applying one of those, right, to this, and I get that shape right here. Now what? So there's my shape for one of these. Now what?
Did you graph the other one?
Okay, so what do you want to do? Up, down, left, right, or 180 degrees?
Up, down, left, or right.
Which one? You have 3 choices. This is
Up, down, up, down.
up, down. I chose left and right. It doesn't matter, right? But you choose one. I'm going to choose left, right symmetry because it has all 3. So I'm going to choose pi over 2 symmetry. So right becomes left and left becomes, and you would get that. See what I did? I took the right side, that would be the top portion, traced it over here. That's this. And then I took the left side, that's this portion right here, flipped it over here, and that's this part. See what I did? Okay, so that's left, right, but now I need to do up, down. So take this, top becomes bottom, bottom becomes top. So this whole thing on the bottom flips up. These 2 things on the top flip down, and I would get that. Well, that's 2 symmetries. What do we do with the last one? What do you do for symmetry with respect to the fold? Turn it
To the side.
180 degrees. So flip this 180 degrees. Watch me. I just did it. So flip this 180 degrees. Watch me. I'll do it.
Because it's all the same.
It's the same. Now, that's not always the case, but in this case, it is. They call this.
The road.
Does that look like a rose to you?
No.
That's a bad one. The snail one, okay, I can kind of see what they get. That doesn't look like a rose to me. It looks like a 4-leaf clover, right? But it doesn't look like a rose. All right, write this down. These are the ones that everyone, it's not a girl thing or a guy thing, but everyone's, ooh, I want to make flowers. So she made one with a umpteen. Guess how many petals yours have?
8.
Why does it have 8?
What 8?
Okay.
This is a crazy flower.
It says that if n, this is the formula right here, if n is even, what was your first number?
8,
What was your second number?
8.
8. So if your second number is even, right? 2 into 8 goes 4 times, so that's 2 times 4, so it's going to have that many petals.
I make it negative.
Oh no, A can't be 0.
No, the N.
Well, it just matters whether it's even or odd.
So if it's 7, probably.
It should, if you make N 7. So if you did 8, if you just change that second 8 to a 7, it should have 7 petals.
Ew.
Count?
I like that.
Did you just call his rose ugly?
No,
He just gave you a rose.
made him make that I picked.
So you gave him an ugly rose.
Yeah.
Yeah, that was pretty ugly. But it does have 7 petals, right? To me, these look more like daisies. They don't really look like roses. How many did you do? 10?
Deadly weapon.
Yeah, it looks like a ninja star thing.
Oh, yeah.
20 and 30.
Your calculator will probably not draw something accurate if you put a big number in it.
7.
You put 100, what did it draw?
It just drew like.
Yeah. Okay,
Oh my goodness.
are we okay on roses?
Why can't we just talk about roses?
Because there's more. All right, so cardioids, lemnisons, and roses.
Ow, what?
Doesn't look too bad. Those are more snowflakes.
You know
than-
the spike balls are like.
All right, there are 2 left. Here we go. What do you notice? What's different? Square sign. This should be a flower, right?
No.
We got a 4, we got a 2. It should be a flower, but we got R squared, so this will not be a flower. All right. So determine the symmetry. Here we go. Negative on the inside, turn sign.
Negative.
So no bueno there, right? What about this? Same trick again. Distribute the 2 and we get 2 pi minus 2 theta. So the 2 pi goes. The 2 pi goes away. And then we got a negative. So once again, we got to bring the negative to the front. So that's no good. Well, we better hope the last one works. The last one, well, yeah, because it's all positive, right? So this one does work. Okay, cool. So this one has symmetry with respect to the pole. All right, what do I do? Before that, table of values for pole, that was between 0 and 180. We toss those values in, we graph those values, and I get that shape right there. Ready? Now what? Flip it how many degrees? 180. So this would now be here, and I would get this. All right, what does it look like? Looks like infinity symbol. What else?
Half of a flower.
Half of a flower. I like that.
Color hat thing.
So guess what they call it? They call it not the hat. They call it the propeller.
Why can't that be infinity sign? It should be.
I'm with you, right? So they call that right there, but in French, propeller is not propeller. Propeller is lemniscate. So here's another word. There's your propeller right there. So it's called a lemniscate. It's also the French word for ribbon as well, too. A bow, we would call it probably more like a bow.
No, always gonna have to do something.
Yes. And remember, if it doesn't have a 2, you can always force it to have a 2. Divide by 2, put that in there, and then multiply by 2, and now you got a 2.
You should make a star.
You can do that with the roses. They made one over here. Just add enough kettles and it's gonna, your graphic calculator will turn into it.
Yeah, like a actual like star. Did we do that?
Oh, yeah. All right, last one. All right, hey, what do you notice immediately? Doesn't have any trig here at all. This is an exponential. So this is the Euler's number, right? Is the special number E, 2 and some change, to the theta. The theta is going to be an angle over 5, right? Go ahead, graph.
You want us to just
Yeah,
drop?
just grab it. Your calculators don't do a very good job of this one. This one, as you're graphing, has no symmetry. If we apply the rules for symmetry, well, we got nothing. There's no trick to involve with exponents. Exponents are just exponents. So that black isn't equal to that red. So note for that. And well, pi minus, there's no trick involved here. It's an exponential. It's not, right? It's not a circle. It's a. It is not an oval.
You got a swirly.
You get a swirl, right? So this one has no symmetry. You get this shape right here. You should get this on your calculator.
It's.
Yeah, some of the older ones really have shown. Do you have any programs on this? Sometimes I'll just clear it out. Oh no, let's try and draw it. It drew it. It just really you have to zoom out.
Okay, cool.
You're really zoomed in.
No, I'm not.
I'll do that next time.
I'll do the other one next time.
Look at the calculator. Or look at Seth's calculator. You get it? Yeah. So, like I said, some of the calculators do a very poor job of this. Turns out, I'll show you this real quick. Turns out if you do this in Desmos, I would encourage you to do this on your own. I'm not going to share this with you, Ish. We're just looking at that program in Desmos. You can type it in your computer there. But if we do this in Desmos, you can tell that it's actually a spiral. And no matter how much you zoom in or zoom out, it's always a spiral, right? Keeps going forever. Now, your calculators do a really bad job of graphing this. And even Desmos eventually gives up and it says, I'm not doing any more than that, right? But if you zoom out, you get a repeated spiral. And then finally, Desmos says, I've spiraled enough and I give up. So it kind of stops right there. But it goes further. If I continue to zoom out, I maintain that shape. Yeah, exactly. Or give you a stroke or something. All right. So write this one down. This is the last one. This is a spiral. No weird French name. Actually, I don't know where the word spiral comes from. What language it comes from.
It's probably like.
Hey Siri, what's the origin of the word spiral?
The word spiral is derived from the Latin word spira.
I told you.
Which means coil.
I said it
helix.
Spira, coil or helix. Latin. So does inspirate mean to spiralize someone? Can you inspire someone? You're inspirational.
You see how much trees are cut down?
All right. There are all the shapes we have. We learned a little bit of French words and we learned some weird, funky shapes and we learned the procedures. All right. Hey, remember physics?
Yes.
Remember when I said that eventually we would talk about what you did first semester? Vectors?
I don't want to learn about vectors.
You already know about vectors. So the rest of the chapter should be a review for all you seniors. For all you juniors, not so much. You don't remember vectors at all?
Chug down the monsters.
All I remember is Vector from Despicable Me.
When's our pizza day?
When do we want it? What?
Manana.
Why does this feel like this was not recording? It started recording in progress.
You stopped this.
No, it did it. It did it.